Hi team, thanks for joining the call. Only four people joined, right? Let's give Deepthi 2 more minutes. So once she joins, then we can start. Can anyone quickly ping Deepthi in the group? Okay. Thank you. As everyone is here, let's quickly start today's class. Okay. Um, today's class, have you gone through the document again? So you guys has any doubts or anything? Because you mentioned you will go through the recording again, right? So you have any doubts from the yesterday's class? No doubts. Okay, fine. My voice is clear, right? Clear and audible, right?
Yes, sir. Yes.
Yes, sir.
Okay, cool. Okay, let's
Sir,
quickly.
can you please share us this PPT?
I'm meant to share now. Wait. Just give me 1 minute. Right away, we'll share this document. Otherwise, I forgot. If I haven't shared, you could have asked yesterday only. Mm, okay. Um, I kept it somewhere. Where is this? Where is this? Come on. Okay. Okay, sent. Mm, okay. Yeah, send the document. Okay. So you can go with that document.
Sir, are you planning to tell us which part who has to explain for the demo?
No, you're there in the stress class, right? Or no,
Yes.
actually, you are supposed to work on all the concepts. Like you guys needs to work on all the concepts. Let's say in the first PT, right? In the first PPT we discussed, right? Just pick all the concepts because there is no such important concepts. We only you guys need to come up with all the concepts. I mean, there is no particular, but you can divide it, connect as a team, and then you can decide. uh, you become two teams, okay, two teams, and each one pick a different topic. That's a better way. Otherwise, if you single person, right, then you need to uh, I would like to you go all the concepts with all the concepts rather than having some particular concept, because all these things are interrelated. Okay, so if you pick one concept and if you try to understand, then you need to go back to that concept and understand that. Then you need to come back to this previous concept, like that. So which way you want to go, team or individual? Okay, it's up to you. By the end of this class, you can just let me know. Okay, so team or individual. I remember yesterday or day before yesterday you mentioned, right, you wanted to go with individual only. See, if you are going with individual, just let's say till you done any practicing, or sorry, you came through any concept. Okay, let's say the storage, persisting and caching concept. Okay, now I would like to see in your PPT or place where what is this persist and caching. Okay, so in your plain words, okay, persistence means this is this, it has storage level. Caching means without by default storage of this persist. So something like that, memory and disk. So okay, then I would like to see like what is this memory and disk. I'm not asking for memory and disk serialization or deserialization. No, just go with memory only. Okay, memory only and memory and disk. How this happens? Memory only in disk two, memory and disk two. Right? So we have seen this, right? See, memory and disk two, memory and disk only two, and disk only. So like this. So I just want you to pick these things and just explain. Okay, do not need to give entire things. Okay, just pick these concepts again in the call, right? If you are giving the demo, right, I might ask you, right, what is this disk only? Then you're supposed to say disk only means Spark will store this cache this entire data which we asked it to do in the disk only disk. Okay, so maybe this disk memory and disk, that means half in the memory, half in the disk, something like that. So you can come up with that answer, but just try to put this key points there. I do not want to prepare in super excellent PPT. No, if it's a plain PPT just with the normal words, absolutely fine, but I want you to learn the concept. That's it. That's why we planning this demo. Other than that, nothing. Okay, so I do not want to have some good pictures, so good images, good diagrams, good tables and all. So don't spend that much enough amount of time. Just if you have any available resource, just pick it up. If not, just ignore that. Okay. Um. Okay. So by the end of the class, let me know what to do. Okay. So this repartition and collision. Okay. So when repartition and collision, you wanted to explain on repartition and collision. Do one thing, then prepare a repartition. What is repartition? What are the places, what are the situations you are going to use repartition? Okay, repartition is used for two things. One is increasing number of partitions, one is decreasing number of partitions. What happens with increasing number of partitions? What happens when decreasing partitions? Why we use collies? If you have decreased partitions with the help of repartition, you can decrease number of partitions. Then why we have collies? Right, so collies is for just decrease the number of partitions without large shuffle. Very with minimum shuffle, we can reduce the number of partitions like that. So just come up with these points. Okay, I do not want you to go and prepare an excellent PPT. Okay, no, this is not college nor the project. So just try to for your understanding, just prepare a PPT. Spark Submit and all these things are bit complex concepts. I will explain you. Maybe memory management, Spark Submit. Those are the two concepts still left for you. So maybe by next week we will complete that as well. Yeah. Okay. Okay. Now, uh, let's start. Let's start today's class. So, uh, you find right, Veda?
Yes, sir.
Hello. Okay. Yeah. Okay. Cool. Good.
Yes, sir.
So okay. So today let's start on this concept. Okay. So this concept is very important. Again, you might ask me. You're saying every concept is important because today in this entire classes, right, entire course, we are covering only the important topics. There are topics which are not important, which are good to know concepts, which are not must-have concepts. Okay. So, but for now, let's continue with this concept. Okay, so how to process 1 TB of data in Apache Spark. Okay, so let's start with this. Okay, so now for now this concept may be understandable to you or may not be understandable to you, but I hope it should be understandable to you because we discussed this 1 GB concept, right? 1 GB is divided into 128 blocks, sorry, 8 blocks, because of this 128 MB, 8 partitions, right? That's what we discussed, right? So same concept here, but here comes the memory management as well. But memory management, I need to cover these concepts again, then only you will understand the management concept better. But why explaining it now is, if I explain that and then explain this memory management, it will be a bit easy for you. Okay, so that's why I'm going with this concept first. Okay, then we can come back to that memory management concept. Okay, let's start with how to process 1 TB of data in Apache Spark. Okay, so anyone know how much this 1 TB is equal to in GBs? Okay, so for your information, 1 TB means 1000 GB, 1000 GB. That means, I mean, in real time, we say 1000 GB, but what happens is 1 GB is equal to 1024 MB. Okay. Similarly, 1 TB is equal to 1024 GB. Okay. So 1024 GB. Okay, fine. Now, the first rule,
Hi, Ravi.
see,
Veda is asking public
hmm,
they need to represent.
Ma'am, leave it, ma'am. I understood.
Am I audible, Ravi?
yeah, Subhashri, yeah. I mean,
Uh,
topic wise, right? Hello. Um, Subhashri, am I audible? Mm, this is what happens with this platform. Okay. So if it tries back, then we can discuss. Fine. Okay. First, the thumb rule is the moment you have 1 GB of file, okay, 1 GB of file, then how many partitions you will see? Can anyone let me know? The moment you have the Spark sees 1 GB file, how many partitions does Spark will create for that 1 GB file? Come on. You can
Eight
try
party.
something. Why 8 partitions? Who's this? Sorry.
Dipti.
Yeah, Dipti. Why 8 partitions, Dipti? Anyone? Why 8 partitions? What Deepthi said is correct, but why 8 partitions? Okay. What is the block size in HDFS? Anyone block size in HDFS?
128.
128 MB. Now 1024 MB by 128 MB. Can anyone quickly do it in the calculator and let me know how many partitions you will get? 1024 MB by 120 1024 by 128. 8 partitions. Right? So how we are getting these 8 partitions? Okay, so 8 partitions is correct answer, but how we are getting these 8 partitions is based on the HDFS block size. Spark is trying to read data from the HDFS. Okay, that means HDFS how data is stored. It will be stored in 128 MB of blocks. Okay, so when Spark picks data from the HDFS, right, what it will do is it will make it will make this 1 GB into even it's a 1 GB file, but 1 GB will be divided into 8 partitions because of this 128 MB size. Okay, okay, fine. Now I need to process 1 TB of data. 1 TB of data means how much amount of GB of data? 1024 GB of data. Okay, now 1024 by, which is GB, right? 1024 into is GB, right? By 128. Right, 1024 is GB. 1024 into, in place of GB I need to write 1024 MB. Okay, so 1024 into 1024 by 128, then how much will I get? Let me do the math. Okay, so 1024 into 224.
8192.
Okay, 8192. So 128 is block size. Okay, so 8192. Okay, so that means how many blocks you will see on 8192 blocks? 8192 blocks, nothing but partition. Okay, so just for simplicity we gone with blocks here, but 8192 is number of partitions you will see in your Spark for this 1 TB of data. Okay, but we didn't enter into Spark yet. I'm just talking about the size. Okay, fine. So for 1024 GB, so this is very interesting. Okay, so in interview also they will ask these questions. They will ask these type of Spark cluster questions. Okay, calculations you need to do. Okay, so for this 1 TB of data, 1 TB of data, you have 8192 blocks or 8192 partitions. Let's say in our terminology, let's say 8192 partitions. Okay, till now clear. Okay. Now let's see what is the cluster capacity or cluster size. Okay, let's take 20 executor missions. Okay, 20 executor missions. Okay, executor missions and nodes is a bit different word. Okay, so what happens is an executor means um executor means who which executes the task, right? Node will contain executors. Okay, node think it's so. Wait, let me show you. You guys able to see my screen, right?
Yes, sir. Yes.
Yes, sir.
Okay. Okay, so let's think in this way. This is node. Okay, node. That node you have executor. Executor 1, executor 1. Okay, let's copy this. Okay, this is executor 2. Executor 2. Okay, so executor 1 and executor 2. Fine. Now we have to let's go with very simple concept. Okay, now those are the executor missions. Okay, for your information, these are executor missions, and the big circle I draw is node. This is node. Okay, node. It's a node. Okay, remember that. There is a node, and inside that you will have a executor missions. Fine. Now, 5 core processor in each executor. 5 core processors. What I meant to say is 5 CPU cores. 5 CPU cores. The moment you see CPU cores, what should pop up in your mind? 5 CPU cores means what should pop up in your mind? CPU cores.
Uh, Parallel.
Parallel. Parallel. Five CPU cores means you have 5 parallel tasks. You can do 5 parallel tasks. Okay. So 5 CPU cores. Okay. And 6 GB RAM for each executor node. 6 GB RAM for each executor node. Let's say you have how many executor missions here? 20, right? 20. Then for each executor mission you have 60 GB of RAM. That means how much amount of RAM you will have? 20 executor missions. Okay, if you go back here, there are 2 executor missions. Let's keep it simple. 2 executor missions. Okay, let's keep it simple. 2 executor missions, and each executor mission has 6 GB of RAM. Then how much total amount of RAM you will have?
12 GB.
4 GB. Now, similarly, you have 20 executors. Then how much amount of RAM you will have? 20 executors. Then how much? 20 executors and
120.
6 GB RAM for each, right? 120 GB of RAM, right? 120. Okay. So 120 GB of RAM and 5 CPU cores. Okay. Why 5 CPU cores? Okay. Why I'm taking only 5 CPU cores per executor? Why? Because you can ask me. You can ask me. There are 892 tasks. I mean partitions I need to process. Why can't I take 8192 CPU cores? Okay, CPU cores, and accordingly take the executors as well. And then why can't we execute it? Everything will complete it in the single run, right? So in the real time, you can still go ahead and do that, but it's not optimal. Okay, these Spark engineers, the persons who develop this Spark, right, who optimize the things in the Spark. Okay, so they decided that instead of going with some random numbers or some big numbers to meet the parallelism, right, they decided for each executor, if you go with the 5 CPU cores, okay, 5 CPU cores, it's very optimal for you for your processing. Okay, so it was decided by the Spark developers only, not by me or nor by other people. Okay, the Spark developers who developed the Spark, right, they decided that okay, if you go with 5 CPU cores for each executor node, then it will be optimal for your processing. Okay, so that's why I was taking this 5 core processor in each executor. Okay, now just if someone asks me that how many number of executor cores you are going to take, you can tell one is very low. Okay, you can tell two is comparatively low. Okay, but if you go with 3, 4, 5, it's very optimal. Okay, if someone asks me why you are not taking more than 5, you can say that if I go with 5 till 5, it's optimal. If I go with after 5, it's not optimal. Why not optimal, I will let you know in the coming slides. Okay, but for now, if someone asks you what is the optimal number of executor cores can CPU cores can an executor have is 5. Okay, 5. Now, executor course means parallelism. That's what we discussed. The moment someone says executor, that means you're supposed to learn these things, right? Supposed to strike the parallelism. Okay. So now let me. Okay, this is CPU core 1. Okay, CPU core 2, CPU core 3, 5 CPU cores. Okay, I need. Okay, so 5 CPU cores. CPU cores. Okay, I'm going with 2 executors only. You can think of 20 executors here. Okay, in this node, this different nodes. Okay. Let's go back to the processing again. Now, the cluster can perform how many number of parallel tasks? We discussed, right? Executor cores is equal to number of tasks. So each executor has 5 parallel tasks. Then how many tasks can I do parallelly in each executor? 5 CPU cores will help us to do 5 parallel tasks, right? 5 parallel tasks. So each executor has 5 CPU cores. Now in total, how many CPU cores I have in total for this 20 executors? Total how many CPU cores I will have?
100.
100. Because how this 100 came is 20 executors into number of cores, 20 executors into number of cores per each executor. Okay. So number of cores is equal to number of executors star number of cores. Then number of cores is equal to, let's go here. Equal to number of executors is 20 star 5. That means it will be 100, right? 100 executor cores. Then how many number of parallel tasks you can do?
100 parameters.
100. 100 parallel task. Okay, 100 parallel task. Okay. So total how many number of partitions you need to process? You need to process 1 TB of data. And how many number of parallel tasks you need to process? I mean, how many number of partitions you have here? 8192 partitions, right? 8192 partitions. That's what we calculated, right? So 1 TB of data will have 8192 partitions. Now we need to process this 8192 partitions. Okay, you need to process this 8192 partitions. Okay, we'll come back to this concept again. For now, just remember this. Number of cores is equal to number of executors into number of CPU cores for each executor. So CPU cores for each executor. Okay, number of CPU cores for each executor. Each executor is 5 and number of executors is equal to 20 and number of cores is equal to 100. Okay, now we need to process 1 TB of data. We need to process 1 TB of data. That means 892, 8192 partitions. Partitions in Spark. Okay, we call partitions in Spark and block in HDFS. HDFS. That's what I mentioned, right? HDFS block size. What is HDFS block size? 128 MB. That's why we got 8192 partitions. Okay, super. Let's go back. Okay, so the cluster can perform 100 tasks parallel at a time. That means here task can mean block. So 100 blocks can be processed parallelly at a time. That means simple, right? So you have 100 executor cores available. That means you can import 100 partitions into your cluster. Okay, then you can process those things. Okay, now let's go back to the next concept. Now, now total 100 tasks you can do. Okay, 100 tasks you can do. I mean 100 tasks in the sense 100 blocks you can. 100 blocks you can process in the same time. Okay, 100 blocks. 100 blocks means each block size is equal to how much? Anyone let me know? Each block size
128.
128 MB. And in the first parallelly, you can process only 100 tasks, right? 100 tasks. Now 100 into 128 MB is equal to 12.5 GB of data, right? 100 into 128 MB is equal to 12,800 MB. That means if you convert it into 1024 MB, that will be equal to 12.5 GB. Okay, so because you know, right, 8 128 MB blocks will is equal to 1 GB of data, right? That means this 100 blocks will contains let's say 12 GB of data, 12.5 GB of data. Okay, so we can safely say that 12 GB of data will get processed in the first set of a batch. Okay, in the first set of a batch, 12 GB of data can be processed. How 12 GB of data is processed is let's go back. If I wanted to process 12 GB of data, okay, let's go the calculator again. Okay, so 12 GB, okay, 12 into 1024 is equal to this, okay, divided by 128 MB is equal to total 96 partitions you got. Okay, so for 12 GB you got 96 partitions. That's okay. Why I'm not going with 100 and 100 partitions is the CPU cores, right? The CPU cores I have some CPU cores I need to use for application master. You know, right? Application master. We work with yarn cluster, right? Application master. If you remember, if you go back to the HDFS concept again, there is a concept called application master. The moment you submitted a job, okay, then application master needs to be launched. So let's say one core is gone in that, and the other three cores, right? Some HDFS, there are some daemon processes that are running in the background, so they need these cores. Maybe they need, I think, for each executor, I mean for each node, one executor. Okay, one executor will be gone to this daemon processes, some system related process. This is my system. Okay, this is my system. Have you ever seen that? Have you ever seen that your phone memory, your family phone memory, it says that 128 GB of phone memory. But the moment you receive the phone, how much amount of memory you can see in your phone? It's definitely less than 128 GB, right? Because some data is occupied by the system related functionalities, right? Because maybe OS in phones it's a Android, or in iPhone it's a iOS or something. They will occupy this space, right? Similarly, here also, if I say exact numbers, that exact numbers won't go into the processing side. Okay, they are go into managing side as well. Managing means OS. For OS you need an executor core. Someone needs to like OS needs to be installed in your system, otherwise you cannot perform the actions you can do, right? If there is no OS, can I open this PDF? No, I can't even open my laptop there if there is no OS, right? So for those kind of tasks, some executors, some CPU, RAM and ROM are resolved. Okay, CPU, RAM, and ROM and resolved. Simple. If it says that when you open a Flipkart and Amazon, it says that your laptop memory is 512 GB. But when you see the laptop, it's never 512 GB. Okay, it's never 512 GB. See, it's if you combine all these things, it's never 512 GB for me. They mentioned 512 GB, but it will never become 512. It will come around some 480 GB, 490 GB, maybe 500 GB. Okay, that 12 GB is gone to the system. Okay, similarly, here also, in this case also, something will be used. I won't say exact numbers because you will get to know those numbers later. But some numbers, some portion will be used by the system related task. Okay, OS related task. For now, think of OS related task. Fine. Now let's go with 96 blocks. 96 blocks to be processed at the same time. How many number of blocks I need to process? 8192 blocks. But now I can process only 96 of blocks in the first run, right? We discussed about the batches, right? When we go to batches is we need to make sure we will process everything in the parallel only. But if all the partitions do not fit at the same time, then we will take the number of partitions that fit first. Okay, in this case 96 partitions, I will take 96 partitions first. I will process that, then store the intermediate result of this 96 partitions into some location, then import the next batch will be again 96 partitions, then again process this entire second batch, and we will get the some intermediate output, and that intermediate output will be written into the uh, will be saved somewhere. Okay, I need to access that, right? Again, similarly, I will get. Now, let's see how many number of batches I will get here. Okay, total how many number of partitions we have here? Blocks or partitions, whatever it may be. 892, right? 892. Let's go to the math again. Okay, 8192. Okay, 8192 partitions I need to process, but in the first batch I can process only 96. That will be equal to 85.3333 batches. Okay, because batch size is, if I go here, hope you guys are getting this concept, right? Is it understandable to you or difficult for you? It's very important. Hello, can
Yeah,
you
yes, sir.
first batch? Because if you guys not speaking, then I will think you guys are disconnected from the call something. Okay, don't do any parallel task. Okay, just be attentive. For one batch, 96 blocks or partitions are are processed or executed. Okay, then for 892 partitions, 8192 partitions or blocks, okay, is equal to 85 batches. Okay, 85 batches. Now you understand how the batches happens, how parallel tasks are processed. Okay, parallel task, how parallel tasks are calculated, how batches are calculated. Okay, any idea? You got some idea on this thing? Because it's easy. If you again go and see this video or this page, this PPT itself, you do not need to go through this video again. Just go through this page again, then you will understand this very easily. Okay. Now let's go because there is some order here. Let's see. Okay, so 100 into 128 MB, that means you are going to process 100 tasks at the same time, right? That means 100 into 128 MB is equal to 1024, 1024. Just a second. Okay, so 1024 MB, that means that equal to 12.5 GB of data will be processed in the first batch. And similarly, you will have 85 batches to process. Now tell me, if first batch takes 1 minute of time, then how much amount of time will it take to complete this entire 1 TB of data, process 1 TB of data? One batch takes 1 minute, let's say. Come on.
Can you repeat again?
Okay. One batch takes 1 minute of time. Then how much time does 1 TB of data will take? I will repeat again. One batch will take 1 minute of time to get execute for execution. Okay. Now 1 TB of data will take how much amount of time for execution? How many number of batches will 1 TB of data will have? How many number of batches will 1 TB of data will have?
8192.
Hello, sorry.
8192.
Sorry, I didn't get that thing. How many number of batches will I get? You guys able to follow, right? I mean, we just now discussed, right? How many number of batches we created? I mean, you guys able to see my screen? See how many number of batches we have?
If first batch take 1 minute, then how much time 1 TB of data?
Data will take.
Total batches will be
Hmm.
85. 85 batches.
Exactly. 85 batches.
Um, so 85 minutes.
85 minutes. Simple. Right? But you seems to be very off because maybe you are understanding right, or is there anything wrong or something? Because see, the moment I ask 1 TB, right? I told you the hint I gave you here is one batch. One batch is a hint here. So one batch will take 1 minute. Fine. Now, when I ask the moment I ask 1 TB of data, that means you need to calculate how many number of batches this one I need to go through for this 1 TB of data. How many batches? 85 batches. That's we discussed just now. That means one batch take 1 minute, 85 batches will take 85 minutes. Simple, right? So the moment someone asks you about like the processing time of a 1 TB of data, then you can take any size of cluster. Maybe now I took 20 executors and 5 CPU cores. Okay. You might take 100 executors. Fine. Let's take 100 executors. Super. Okay. 100 executors. Then calculate. Start calculating from that point of time. After this example, let's do that as well. I want you to answer. I won't do anything. I want you to answer on that because this is that important. Okay. So the moment someone asks, so you need to calculate like this. Okay. Now there is one more thing. If that is done, then I will have you done do the calculation for the next thing. Okay. Fine. Now, the RAM is 6 GB in each executor. That means 20 executors into 6 GB of RAM is equal to 128 GB of total RAM. Just perfectly fine. No, right? High CPU cores for each executor, 6 GB of RAM for each executor. That means 5 into 20 is equal to 100 executor cores. That's what decides the parallelism here. Okay, and 6 GB of RAM, okay, into 20 executor cores is equal to 128 GB of total RAM. So that's what decides the total memory, total RAM of your cluster. Perfect. Now, total memory is total memory is 120 of GB. Okay, fine. How many nodes here? 20 nodes. Okay, 20 nodes. Then in the first batch, how much amount of data you processing? How much amount of data you are processing? You're processing the moment you ask someone asks, right? In the first batch, there are 100 parallel tasks. Fine. 100 parallel tasks means 100 into 128 MB of data. That means 12800 MB of data. If I convert it into GBs, then it will be 12.5 GB of data. Okay. So in the first batch, I am processing 12.5 GB of data. 12.5 GB of data. Okay. There are how many nodes? 20 nodes. Okay. 20 nodes. If I divide these 20 nodes by 12.5 GB of data, okay, 12.5 GB of data, then it's equal to how much? 20 by 12, it will be somewhere. Yeah. So 20 by 12 GB of RAM is equal to 1.6 GB of RAM. That means you have 20 executors. That entire 20 executors, 1.6 GB of RAM is being used by this batch 1. Okay. And remaining 4.4 GB of RAM is available for other Spark applications, not this Spark application. Okay, this Spark application can use only 1.6 GB of RAM. Okay, how I got this 1.6 GB of RAM? Because the first batch will take 12 GB of RAM. Okay, 12 GB of RAM. That means that means for each node, like okay, let's see how much amount of data it's taking for each node. That means 20 node by 12 GB will give you the amount of RAM it is taking for each node. Then it will be equal to 1.6 GB of RAM. Okay, 1.6 GB of RAM for each executor. Now, if you each executor has 6 GB RAM, right? If out of the 6 GB RAM, 1.6 GB of RAM is went it out of the 6 GB total RAM, 1.6 GB RAM went for this some task. I mean this first batch. Okay, then how much memory will be left? 4.4 GB of RAM, right? Will be reserved for other user jobs and programs. I mean other users and jobs and programs, other applications, other Spark applications. Similarly, Anusha submitted the first program, okay, first application, okay. Then someone can come and submit the second application as well, right? It can happen, right? Now, for first application, it will use the 1.6 GB of RAM, okay. For the next execution, it can use this for 4 out of this 4.4 GB of RAM. It will use the for if Veda comes and submit the next job, right? Then Veda is supposed to use this 4.0 GB of, okay. Based on the executor course available slots. The moment executors course you see means the slots. Okay. If you see here, I draw this diagram, right? See in this diagram, yeah. So if you see here, I draw this, right? This is an executor, and the executor has this 1, 2, 3, 4, 5 executor course. This is nothing but a slot, you can say. Okay. It's nothing but an tickets. You enter a cinema theater, right? Cinema theater, there will be chairs. Okay, let's say there are 200 people. Okay, only 200 people can go and sit there. Okay, max 200 people. Okay, don't say that you can just go and stand and watch the movie as well. But there will be only 200 max people can fit in that theater. Similarly, the executor course means the number of slots available. That means only 5 slots are available here. Only 5 people can come and fit here. So if someone occupied this, then if let's say out of this two right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 slots available, and someone is already using these 10 slots. Then someone comes and submit their job, right? Let's say Anusha is using all these slots. If Veda comes and wanted to use these slots, she cannot do it. She need to wait for Anusha's task to complete. Okay, so let's move on. What is this? Okay, so in total you will have 85 batches. Okay, so this is how this actual numbers looks like. Okay, now you guys understand this, or do I need to repeat this again? This is very important. That's why. Based on this, we have case studies. That's why.
Yeah, we understand, sir.
Understand, right? Perfect.
Yes, sir.
Fine.
Yes.
So, okay. Good. So let's try to see case studies as well. Few case studies. Okay. Here there will be some new terminologies that will be introduced to you, but do not worry if you do not get it. We again have this memory discussion. It's a memory discussion is some very important concept. Very again important concepts. All are important concepts only. But memory management, right? You see here there are many things here. Node manager, executor container, heap, executor memory, storage memory, user memory, reserved memory, off heap, overhead. There are many different concepts involved here. But to keep it simple, I will tell you one thing now. Because if I tell it now, then you people start confusing. But okay, the moment I says my laptop has 1 GB of memory, that means entire this 1 GB of memory is not going to used for processing. Okay, out of this 1 GB of memory, only 60% will be used for processing. Okay, only 60%. Rest 40%, right? They will be used for user memory, reserved memory, executor container, node manager, different things. Okay, I will show you the exact numbers, but actually in the real time, if I says my executor container contains 1 GB of memory. Okay, 1 GB of memory. That means out of that 60% is only used for processing of the data. Okay, the rest 40% will be used for system task, OS related things. Some user need to some user needs something, right? The Spark will contain need some data. Okay, so OS will run it. Windows 10 or 11 will run your system, but that occupies some space. Spark will run your system, that will occupy some space, right? And half heap memory, like there is garbage collections and all. It's a different concept, you know. But yeah, garbage collection also. For all these things, there are some unreferenced objects in your program. So for all these things, this this 40% memory will get used. Okay, just remember that. Okay, out of this 1 GB you provided, only 60% is used. Okay, for processing. Okay, now how to process 1 TB of data in Apache Spark, you guys know, hope you understand that. Okay, now case studies for resource allocation. Okay, so this case studies I'm just giving 3, but if you Google it, you will get many case studies. Okay, but any case studies, the uh, concept is very simple. Okay, the moment number of executor cores, max, okay, max or optimal value, you can say, you can have for an executor is executor core size, CP cores is 5. Okay, 5 CP cores. Just a second. Okay. Sorry, Ravi. Okay. Fine. Now let's see this case study. Okay. So we have six nodes, and each have 16 cores and 64 GB of RAM. 64 GB of RAM. Six nodes, six nodes, six nodes. You have six nodes, and each node has 16 cores and 64 GB of RAM. Now you need to find how many number of executors you will have. How many number of executors you have. Okay. Let's go. Let's go there. Let's go there and see how many number. Okay. So I have six nodes. Six nodes. Okay. And 16 executor cores and 64 GB of memory. Okay, fine. Now let's see. My task is to my task. I'm an interviewer. Okay, I'm asking you. I have six nodes. I have 64 executor cores. I need to have 64 GB of memory. Now my task is to find how many executors are in this cluster. Number of executors available. Okay, available. Okay. Now the first concept. Let's see. How many executor cores you have here? Let me know. How many executor cores? Executor cores means what? First thing,
16 executor cores.
16 executor cores. So executor core means nothing but CPU core. Okay. Don't get confused. Executor core means nothing but CPU core. Okay. Let me put it here. CPU cores. Okay. Okay. Six nodes, 64 GB of memory. Okay. Now, now, how many executors we can have? Okay. Before having executors, how many number of executor cores can an executor have? Okay. How many number of executors can an executor have? What is the
16.
optimal value? Sorry, sir. No. Okay, let me rephrase this. What is the optimal value for an executor? Okay, optimum number of executor cores can an executor have?
Five.
Maybe you. How many?
Five.
Exactly. Who said this? Optimal
Rita.
value. Ida. Nice. So optimal value for executor cores per executor is 5. Okay, 5. Now I have 16 executor cores. Okay, 16 executor cores. I mean for each node. Okay, for each node. Each node I mentioned here, right? So this is the node, and these are the executor node. This is the executor mission. Executor mission. Okay, and this is the executor mission. Okay. Um. Now let's go here. Okay. Now executor is equal to executor is equal to how many executors can an CPU cores can an executor have? How many CPU cores can an executor have?
16.
No. You're speaking about node, but no, I'm talking about executor. Executor. So never get confused. It's a node. Node means this mission you consider as a node. Okay. In that mission, you can have executors. Executor means it will contain some number of CPU cores plus some amount of RAM, some amount of ROM. Executor. Executor means who execute the task. Container you can say or something like that. Okay. Again, I'm repeating. How many uh, how many number of CPU cores can an executor have?
100.
Oh, no, 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 no. What is the optimal value for CP cores? Optimal value, what is the optimal value? How many number of max can an executor have?
4.
5.
Four,
4.
five. Okay, five. Maximum is five,
5.
right? Five. Okay. So now out of these 16 executors, okay, what is my task here? First thing, what is my task here? My task in this concept, in this problem, what is my task? What I need to do? What I need to calculate here?
How many
How many
executors are?
executors?
How many executors are there? Okay. Now I will take first executor, and assign 5 executor cores to it. Okay, 5 executor cores to it. Okay. Now I will take 2 executors, second executor, and assign 5 CP cores to it. 5 CP or executor core, whatever we call it as. Mostly let's go with this only. This is the industry term. Okay, executor cores. Okay. Now third executor, I'll take third executor and assign 5 executors to it. Executor CP cores, executor cores. Okay. Now how many executors are done here?
15.
How many?
15.
15. So total how many we have?
16.
16. That means let that means you will have 3 executors here. Okay, 3 executors. You guys understand how we calculated these 3 executors? Simple. I'm again reiterating. You have 16 CP cores. The moment you see CP cores, I won't. I will never say there are two options here. So two options here. I will say that. Okay, your cluster size. There are two ways you can put a cluster size. Cluster size is equal to is equal to earlier you saw it 20 nodes, sorry, 20 executors, comma 5 CPU cores, comma 6 GB of RAM. Okay, that's what you see. Or I will put it this way. You'll have 20 nodes, not executors. Okay, 20 nodes. And I will mention 64 GB of RAM. Okay, and there are two options to me. Two options to me for give you that either I will go with the 16 executor CPU cores, or I will give you number of executors. Let's say if I give number of executors is equal to 3. I'll give you 3 executors. The moment you see 3 number of executors, okay, for each executor, how many CPU cores you can have? Tell me. For each executor, how many CPU cores you can have? Optimal value. Whenever I say you can have means optimal value. Max you can have. If someone asks you how many max so you can have means let's consider the max value. You can have one as well. You can have zero as well. There is no CPU core. There is no execution happen in that execute. That can also happen. But the max someone says is what is the optimal value for executor? How many number of CPU cores can an executor have? Hello. How many number of CPU cores can an executor have?
5 CPU.
Who dropped? 5. Someone got dropped, right? Anusha seems to be dropped. Okay, 5. Okay. The moment you see an executor core, that thing that needs to come pop up into your mind is number of executors is equal to 3. Then how many number of CPU cores will these executors will have? For three executors, there are 3 executors in your cluster now. Okay. Then how many CPU cores you have in that cluster? You have 3 executors. Okay. Then how many? Let's say CPU, I will call it as CPU core, or you will call it as executor core, or anything. How many cores you will have? How many slots, or whatever you call it as? See, again I'm repeating. One
12.
executor can
12.
have 12.
Sorry. 9, 9 balance.
How 9?
I mean, We have I'm 64 GBs, right? Sir?
No. Forget all these things. I'm just asking. You have three executors. How many number of CPU cores you can have?
15.
15. How?
3 into 5. Each one 5 CPUs.
Each can have five only, right?
Yeah.
That's what we discussed. That's the optimal value. So an executor can have only
Can't hear
limit.
you.
Okay, we can't hear you.
No.
Sorry. Now I'm audible.
Yeah.
Yeah,
Is it
yes.
is it better? Okay. Okay, so remember one thing, an executor can have five CP cores, okay, at max, because it's the optimum value set. But in the real time, right, if you ask for 100 CPU cores, you will definitely get it, no problem, per each executor, no problem. But it's not suggestible, it's not ideal, it's not optimized. Okay, it's not optimal in the sense it's not a good practice. It's a very, very bad practice. If you do it, then your job will might fail in the middle. Okay, you can face critical memory issues. Okay, so that's why always go with five. Okay, so in each executor you'll have how many CPU cores? Each
5
executor will
CPU
have
cores.
Right.
5
5
CPU.
CPU cores. 5 CPU cores. Perfect. Now, here I haven't mentioned the number of CPU cores, right? In this example. This example, I haven't mentioned the number of nodes. Okay, that you can leave it, no problem. Nodes and all, like you will never care.
So
You have
here
10
it will be
nodes,
3 into 20,
3 into 20. What 3
like
into 20?
60 executors or something.
Yes, no. Okay. You're saying about number of CPU cores, right?
Yeah.
12
What
into
or
5.
number of
12 into 5 equal to 60 GB, right? Sir?
Let's keep it simple. Let's go it one by one. Okay, number of CPU cores here. Let me know. Number of CPU cores is equal to how much here? Let me know. First thing, want you to answer. Let it take 1 hour, half an hour. I won't say anything. I want you to answer. Anusha, Deepthi, Arun, Veda, and Karthik. So you need to answer. Number of CPU cores in this. Okay, just see this one. There are 20 nodes, 64 GB of RAM. Number of executors is equal to 3. 3 executors here. Let me remove this as well. We put 3 as well. The executors. Okay. Now let me know how many CP cores, number of CP cores in this cluster. Simple. CPU or executor cores. You can call anything. Executor cores or slots. Come on, you just answered it, but still, why? I'm not sure. You just repeating my answer, or you just understanding the concept.
15 executors.
15. How 15?
3 executors into 5 CPU cores.
The executors
No, 15
star
cores.
5 CPU.
ICP cores. Optimal value, right? This is optimal value. Then you'll have 15 CP cores. Okay, equal to 5. Sorry, 15, right?
Yeah.
15 total 15 CPU cores. So how many parallel executions you can do?
15 parallel execution.
15.
15. Okay, 15. So let's say you have 2 GB of 20 GB of data. 20 GB of data again. 20 GB of data. Then how many number of partitions will that 20 GB of data will get?
4.
No. 20 GB of data will be divided into how many number of partitions? Partitions. 20 GB of data will be divided into how many partitions?
5, sir.
Sorry? 1 GB is divided into how many partitions? No. 1 GB is divided into how many partitions?
8
1
partitions.
GB, 8 partitions. Then 20 GB will be divided into how many partitions?
160.
160 partitions, right? Here, out of these 160 partitions, how many partitions you can process in parallel here? So how many parallel tasks you can do here? How many number of parallel tasks here?
15 parallel.
15 parallel tasks. You have how many partitions to process? How many? You just said the answer. I'm not sure you're doing some parallel task or you're not being attentive. You just answer, right? For 20 GB of data, you have 160 partitions. Put that aside. 160 partitions. Just remember that 160. Okay. Now,
So
in this, sorry.
I'm really confused, sir. Can
Hmm.
can you reteach the whatever you have taught? Like,
Okay, fine. Do one thing. Do one thing. Go through this video recording again. Okay. Go through this video recording again. And tomorrow or Monday or whenever we next time meet, right? Mostly Sunday, you're going to do the demo, right? We are going to meet on Monday. Then, if still not understandable, then I will explain it. But if you go through this recording again, I'm pretty sure you will understand the concept. But while going through this
Okay, sir.
document, this recording, right? I really request you to do two things. Okay, just put away your phone and everything aside, and ask you no one to disturb you. Okay, next 1 hour or next 2 hours, like, how much time will it take you recording? No problem, keep it slow. If it's very fast, keep it slow. Okay, then try to note the points I mentioned there. Okay, try to note the points. Write it on pen and paper. Take pen and paper. Okay, take like how many number of executor cores, number of CPU cores. Sorry, CPU and executor is same. Okay, so how many number of executors, nodes, CPU cores, RAM, everything, just write it down. Okay, and then watch my recording. Okay, then I'm pretty sure you'll understand this. The answer is here only, but it's just that you're not catching up. I'm pretty much okay with that. Okay, because these are very advanced concepts. These are the concepts. If you master these concepts, then it's interview is very easy for you. So because these are that complex, okay. So that's why you are not understanding. No problem. Just go through this recording again. And if still not understandable, that's okay. Definitely on Monday we are going to discuss this concept again. Okay. So that's it. Okay. To the question I'm asking here, right? There are 160 partitions here. Okay. 160 partitions for this 20 GB of data. I mentioned that 20 GB of data. Okay. Let me put it here. I will give you I will share you this as well. Okay. There is 20 GB of data I need to process. That means I told you, right? 1 GB is equal to 20 partitions. Okay. Then for 20 GB is equal to 8 partitions. 20 into 8 partitions, which is equal to 160 partitions, right? Now, how many parallel tasks I can do here? Task is equal to, I told you, right? Number of CPU cores is equal to number of parallel tasks. We have 15
15
here.
parallel.
That means
15.
equal to 160 partitions by 15 will give you, I mean, in the first batch, I can process only 15 partitions, but I have total 160 partitions. Then 160 by 15, that means around 10 or
10.6.
11.
10.6.
Okay,
11.
let's say 11 batches you will have. Okay, see, this is how you calculate. If one batch take 1 minute, 11 batches will take 11 minutes. Okay, so this is how you will calculate these things in the real time. Okay, now how this RAM is assigned, this everything is said. Okay, the 50 task you can process at the same time, right? That means 15 into 128 MB of 128 MB of data can be processed in the first batch, the single batch. Let's say not first or last, single batch. Okay, single batch. That means 15 into 128 MB. Let's calculate that. So I mean,
1920.
how much?
1920.
1920 MB will be processed
One batch.
in one batch. in one batch. Okay, 1920 MB. Okay, if you convert it into like maybe it's around 1.8 GB or something. Let's keep it at 1920 MB. Okay, now for out of this, how many executors I have here? 3 executors, right? 3 executors. Okay, so 3 by, let's say each executor has how much amount of memory? Each executor has 65 GB of RAM. If you see here, each executor has 65 GB of RAM. Okay, that means 3 into 64 GB of RAM is equal to my total RAM. That means 64, 128, 128 plus 64,
190.
192. 192 GB of RAM I have here. Okay, now let's do, if you do 3 by this 1.8 GB, okay, let's say 3.1 GB, let's say it will give you some 2 or something. Okay,
1.6.
how much?
1.6.
1.6, huh?
Yes. Yes.
Mm, okay, let's leave it for that now. Because I just wanted to see how much amount of memory that each executor will occupy. Okay, simple. We have other approaches. For each executor, one executor will have will have 5 CPU cores. Okay, 5 CPU cores. Okay, that means 5 into 128 MB blocks, 128 MB. That means equal to 5 means
6.
5.
6 what?
How much?
6 4
640.
0.
640 MB can be processed. Okay, that means in one executor size is 64 GB. Right? One executor size is 64 GB. 64 GB. Okay, so out of this 64 GB, 5 CPU cores will be used. That means 5 into 128 MB you can process at the same time. That means 64 MB, 640 MB is processed. Okay, that means the 64 GB, out of the 64 GB, only 640 MB is used. Okay, so 640 MB by 64 GB is used for the first batch. I mean, sorry, for the 5 task, for one executor, let's say one executor. Okay, now for two, let's change this math again. 3 executors means 3 into 64, 192, 15, because 15 CPU cores, right? 15, 15 into 128 MB means how much? 15 into 128 MB,
640.
640 into 128 MB, 1920.
Sorry, 190.
1920. No. Something is wrong. Earlier also 5, for 5 also we got, okay, 5 we got 640 MB, right?
Yes, sir.
For 5 we got 640 MB. For 10 you will get 1280 MB. So for this you get 1920. Okay, we already calculated here. Okay, sorry. 1920 MB. That means out of this 64 GB, 1920 MB is used for one batch. Okay, so I hope this is how you calculate the things. Okay, and let me share this thing. Okay, I'm not sure whether I can paste it here or not. If I paste it here, you guys able to take it from here now? I guess I cannot. I think I'm not sure how I can share this. Let me check. Okay, so that's how you calculate. Okay, so no problem if you are guys unable to do, unable to understand this. That's okay, fine. It happens. Okay, but just I want you to put efforts. That's what I want. Put efforts. If you are able to put efforts and still not understandable, then I'm absolutely okay. But seems like you're not putting that efforts. Okay. You, okay. So something it will ask you like this, loading external trying into replacing your existing content. Just do that export as image or something. Mm, to do export as image. No. Save to disk. Desktop. Oops. Okay, and title. Let me see if you guys are able to access or not. If you guys access, then I'm okay. I think you won't be able to access it. Super. Okay. But that's okay. You anyway go through this recording, right? Then you can have all these things. This content I shared here. Okay. So that will be good. That's it. That's it for today's class. So, any doubts? You mentioned you'll go through this talk recording again and get back. Okay. But my humble request is to just keep all deviations away. Take a pen and paper. Take pen and paper. Sit down and then start practicing. Then start going through this video. Okay. Then you will understand this concept a very better way. Okay. Just try to do that. Then still, if you're not understandable, then let me know. I will help you out. Okay, that's it. Now, where are other two guys? Anusha and Arun. Okay, fine. So we are going to meet on Sunday, right? Sunday at what time? You guys need to
Sir,
decide and tell me, right? Yeah.
sir, about the demo,
Hmm.
till what concepts do you want us to like
Okay,
do the
that's it.
demo?
Okay. So till now, what are the concepts we covered, right? Those concepts you can consider. So till one, what concepts we covered? Okay. So first PPT we covered everything.
You
First class
want
PDF,
first
right?
PPT and second PPT both?
No, first PPT we covered everything. So every
Yeah.
concept from the first PPT. Okay, one
Okay.
thing. Second thing, in the second PPT, persisting and caching. Okay, persisting and caching and data skewness. What is data skewness? That's it. I do not want anything. What is data skewness? That's it. You know what is data skewness. Out of 200 tasks, 100 tasks completed successfully, one task is failing. I'm pretty sure I can write and give you that in any of the interviews. If you give 10 interviews, okay, out of those 10 interviews, in 5 interviews you will face this question. Famous problem. That's a famous problem. Okay, so out of 200 tasks, 190 tasks completed very fast, but one task is taking so much amount of time. Okay, that you will definitely see. So that's what data skewness will do. Okay, just what is data skewness? What is data skewness? That's it. Other than that, nothing. Okay, so repartition and coalescing, you know, right? Already repartition and coalescing, what happens? Okay, salting, no, leave it. Okay, this RDD data frame and data set. I want you to research on this and come back to me, because this is just a plain RDD means this, data frame is this. That's it. So you do not have some good explanation or something. So this is just a readable concept. Okay, this concept. Okay, Spark submit, leave it. Memory management, leave it. Okay, then how to process this 1 TB of Apache Spark. Okay, I want you to hope you guys hearing, right? Recording is happening and everything, right? Okay, I want you to take an example. Okay, maybe I will ask you that, okay, how to process 10 GB of file with 10 executors, 10 GB of RAM each. Okay, then let me know how the parallel tasking, all these things will happen. Okay, so just prepare that concept. But if you feel it difficult, just leave it alone. No problem, no issues. Just leave it that concept. So there are three concepts that you need to ignore for now. Okay, these calculations. Okay, Spark submit and memory allocation. Other than that, every concept we covered, you can prepare and come back. Okay. First PPT full, no doubt. Everything is clear, right? In first PPT, persisting and caching here, data skewness, repartition and coalescing. That's it. Okay, let's keep it till there only. Okay. Again, you can someone can write it. First PPT, someone can put it in the group. First PPT plus persistent caching. First concepts in first PPT, persistent caching concept. Okay, data skewness concept and repartition and coalescing. That's it. Okay, clear now, Vedha? Or you want me to put in the group?
No, sir.
Okay, so first PPT, all concepts plus storage and persist concept plus data skewness concept plus coalesce and repartition. Okay, right?
Okay, sir.
Hmm?
Okay.
Okay, sure.
Okay,
Sure.
sir. Understand.
Okay. If no other doubts, nothing, we can wind up. Thank you. Please go to the recording, and Veda, if you have any doubts, if you guys have any doubts, just ping me in the WhatsApp or something. I will definitely able to reach out to you. The moment you start preparing, you will get doubts, right? Definitely. So if you have doubts, just ping me. Just ping me. Okay, or just you can directly connect with me. Tomorrow is Saturday and Sunday, right? I will definitely be available. Just connect with me, then we can discuss. Okay.
Okay, sir.
Thank you. Thank you.
Thank you,
Thank you
sir.
so much. Thanks for the call. Okay. Thank you. Bye. Yeah. Please prepare. Okay. Thank
Thank
you.
you, sir. Thank you.